everyone, and welcome to our Healthier Buildings webcast. Today we'll be talking about CDC and ASHRAE guidelines on healthier indoor spaces during COVID-19 and how facility managers can implement this efficiently and at scale in their own portfolio of buildings. Your hosts are Bob French, Chief Evangelist at 75F, and two representatives from Dalkia Energy Solutions, Daniel Smith, Business Development Manager, and Eric Moser, VP of Hospitality and Healthcare. Let's get started.
Hello, everyone. And hello, Daniel and Eric.
Hey, Bob.
Really excited to have you guys today. Yeah, we've been talking about these different things to consider in opening up your buildings, the different guidelines, the science behind them, things that people can do to get their buildings open. But we've been focusing our talks really on single buildings, or the buildings that people are operating and managing themselves. So today I'm very excited to have you because when you start thinking about the considerations for doing those things at scale, hundreds of buildings at a time, it's quite different. And the skill set, the capacities, and the processes that are needed are different. And so I really am looking forward to your content today. All right, so before we take your questions, we have a question for you. Just a little temp check here. We're just gonna spend half a minute with this, and the quick poll, I'd like you to just pick one of these. When do you plan to reopen your buildings? So guys, have you heard a lot of people with their buildings open, or do you feel like that's still kind of a question in your experience?
You know, I think that a lot of people headed back to work at the beginning of the summer, and then I think the trends kind of reversed as the spread continued to increase. So
yeah, so I'm very curious to see what people are saying now. So do we have some results? Not quite yet. All right. So it takes a few minutes for the system to come back. I see some of the data already coming in. It looks like about a third of people are undetermined. And here we go. So 52% are already open. That's a little bit lower than I expected. But 11% say within the next 3 months, and then some within 6 months, and 30% undetermined. That's really a great group to be talking about today, because perhaps we could help, with figuring out like what you need to do in order to get your building open. All right, so today we're going to recap the guidelines and the science behind the guidelines. We're going to spend a little bit of time on how ventilation systems work in commercial buildings. We'll talk about how to follow the guidelines and some of the energy implications for following them, followed by a presentation from Daniel and Eric about these things that I talked about earlier, scaling across a portfolio, taking these ideas and scaling them out. Now I'm going to spend a little bit more time recapping our past webcasts than before, just because it has been 3 months now. And so there are a lot of new people on the webcast today. So I'm going to spend some extra time recapping some things here. So let's get into the guidelines themselves. So in times like this, we look to the authorities to help us figure out what do we do. So the authorities that we're looking to are the CDC and ASHRAE. And specifically, the guidelines that we'll be referring to are the COVID-19 employer information for office buildings. If you go to the CDC website, there's a section with that title. And if you go to the ASHRAE website, you'll see the commercial COVID-19 guidance. So those are the guidelines that I'm referring to throughout this presentation. So what I've done here on this slide is I've combined the guidance together into one summary page. So fortunately, they are in accord in terms of the recommendations and guidance. So we don't have conflict in terms of what to do. These authorities are together. The first and most important one that we see is increase the percentage of outdoor air. What we're talking about there is using the economizer modes of HVAC operations, potentially as high as 100%. But of course, you have to understand that the capacity of the unit might limit that, right? And there are indoor and outdoor air quality considerations to take into account when you're making that decision. You want to increase the total airflow supply to occupied spaces if possible. You want to disable your demand control ventilation, which tends to reduce the outside air supply based on occupancy. And that, of course, would be working counter to our goal of increasing ventilation for reasons that we're going to talk about in detail in a few minutes. Flush the air in the building for 2 full hours before and after occupancy. Improve the central air filtration to MERV 13 or higher if possible. And you'll be limited in terms of what's available at your system. And then use methods to physically separate employees in all areas of the building, including their work areas and other areas such as the lobby, the meeting rooms, and those places where people are going to be together. And then we also had a full webcast about partial occupancy and strategies that you might employ during those times. So first, let's just cover the CDC here in terms of information that we've received from the CDC and that we follow regularly. I was just checking this morning. So first of all, how COVID-19 spreads, right? It is thought to be mainly from person to person and people who are in close contact. I think that this diagram that they've got up here is really helpful to help us understand how the infection can be spread from one person to another. But it's all about the respiratory droplets. And we're going to talk more about those droplets in terms of their size and some factors to consider in how far the droplets will spread and how easily other people can pick them up that way. So these droplets then, if they're in the air, can land on the noses and mouths of people in the room, and that's how they can get infected. You can also get infection, although it's thought to be a little less likely, by touching surfaces and objects that have the virus on them. So this is what the CDC is teaching us about the transmission of the disease. Now, we've also been doing quite a bit of research with other scientific agencies to help support and more fully understand why these guidelines are in place. So the science that supports the guidelines. So we have a study from the American Society for Microbiology. And this is where we start understanding that there is a concept of concentration or a dosage. Just think about like when you're getting a medical prescription, you're getting a dosage. There is a concept of dosage with COVID-19 too, and it's concentration. And since it's in the air, what we're talking about is the concentration of the virus particles called virons that are in the air. So this idea comes down to how do we reduce the concentration and therefore reduce the dosage and for any given length of time. So increasing airflow rates that simply increase the delivery of recirculated air, which is what I hear often as the interpretation of this, isn't actually helping you at all. It isn't about recirculating. It isn't about the amount of air. What it's all about is the amount of outside air. And in just a minute, I'm going to show you an illustration of what I mean by that. And there is a difference between recirculation and ventilation. So we also understand from ASM that the relative humidity in the space has a big influence in the size of the droplets and therefore the distance of transmission. And in fact, we found a study from ASHRAE which helped us understand the settling rates. If you'd like to know where that 6-foot rule comes from, it comes from this idea. The bigger the droplets, the faster they drop. And so one of the things that we learned is that there's an ideal range of indoor relative humidity that you are going to be shooting for, 40% being the minimum. But of course, indoor relative humidity does get bad at a point. So there's an upper limit as well, and that's 60%, because above 60%, you're introducing other possible problems like mold. So you're really shooting for 40 to 60% indoor relative humidity to keep the droplets dropping down quickly and not floating. And so this has been a subject, even for the last several months that we've been tracking this issue. It has been talked about quite a bit. The New York Times came out with an article a few weeks ago about how hundreds of experts around the world are really saying coronavirus is airborne. And the World Health Organization recently came out with a statement, saying something similar. So as far as we're concerned, we're looking at the guidance, we're looking at the experts, we're listening to the scientists, and we're treating COVID as an airborne transmission risk. So in order to understand what I'm talking about with these factors, let me just talk about how ventilation systems work in a commercial building. So here's a little diagram that shows how air flows through a rooftop unit. Now, a built-up air handler would work in a very similar fashion. You'll see this red arrow on the left is the outside air. It's kind of like opening up windows in your building and that outside air coming in. But of course, there's a fan, right? And the fan is actually sucking that air in from the outside. And you'll see that the yellow arrow is coming up from down below. That's the return air. I mentioned a minute ago about the recirculation. So the yellow arrow is indicating that air is getting recirculated. And when you open up the outside air damper very widely, you need to actually have an exhaust fan. And you'll see there's an arrow coming out of a motorized or exhaust fan outlet there. And so that's how we balance the total amount of air that's going through the unit. And you can see now that if we open up the outside air all the way and close the return air, then you're going to have nothing but a solid outside air coming in. That is the ideal. That is what the scientists are saying is the best remediation effort that you can make. And then it comes through and gets conditioned, and you'll see the blue arrow coming into the building. So that's how these systems work. You might also have what's called a dedicated outside air system. These systems would be found in places where your heating and cooling is provided by non-ventilated equipments like fan coils and heat pumps, right? They don't take any air from the outside. So you have to add that outside air through a dedicated system, like this. So those are the two principal means that you're going to find ventilation in commercial buildings. So let's just talk about how to follow these guidelines. All right. So when we talk about sequences of operation, that is the sequence or the steps that we're going to command the equipment to follow as it responds to the different conditions in the building. So during occupied hours, the guidance is to open up the outside air dampers as high as 100% if you can. And that's a caveat that's sometimes hard to follow, especially at this time of the year. It's kind of hot here where we live. You want to purge the building with fresh outside air for 2 hours before and after the occupied hours, and disable demand control ventilation. That's the sequence that uses the CO2 sensors to automatically adjust the amount of outside air. And for VAV systems, increase the discharge air temperature to the max to encourage VAV terminal dampers to be as open as possible. Now, so the sequences of operation for outside air damper maximum opening. It really kind of depends on the kind of equipment that you have in terms of how to follow these guidelines. So first of all, you want to get on the roof and open up your outside air damper. Now, what is the outside air damper? This little drawing or this little photo I have on the right side of the screen is what we're looking for. Now, you would find that if you have a thermostat and you don't have a very large system, say less than 5-ton rooftop unit, you might have a small outside air damper like that. So if you can, you try to open that up as much as possible. You will find limitations to this because the equipment might not be able to keep the building cool when you open it up all the way. So you might have to be getting up on the roof several times in order to find the place, or actually several times per day even, given that between the morning and the afternoon, temperatures are changing quite a bit. If you have an economizer, which is like this but larger, then you're going to want to call an HVAC tech to come out and adjust what's called the minimum damper position to as high as 100% if you can. If you have a typical building automation system, you want to edit your settings for the outside air damper so that minimum position is as high as 100% if possible, and have that person disable the demand control ventilation. For buildings and our customers that have a 75F automation system, we have all that pre-packaged. You just push the epidemic mode button and all that automatically takes place. Not only that, what we found is that the ASHRAE and CDC guidelines are changing. We keep up with those, and all of our updates are done over the air. So as those guidelines do change, those are automatically included in that feature. You don't have to worry about them. And when the pandemic is over, you just push the button again, and the system will return to the deep energy savings that we're known for. So the sequence of operation for pre and post purge. This is where you want to purge that air out for 2 hours before and after. If you have a thermostat, really your only choice is to change your occupied hours for 2 more hours before. So you're going to be adding 4 hours of operation per day to do that. That's really your only choice if you just have a thermostat. With a typical BAS, you can perhaps edit so that the fan only is coming on for 2 hours before and after operation. With the 75F epidemic mode, what we've done here is automatically engage that fan, and we're watching indoor temperature and humidity to make sure that the buildings do not go outside of the setup or setback temps and the building limits, and it will automatically stop with enough time for Athena, which is our building intelligence system, to figure out what the optimum start requirements are to get the building to the desired set point by the time the scheduled hours begin. And again, this is all automated and updated over the air if the sequences change. Okay, so maximizing the discharge air temperature, this is, and for VAV systems in particular, what we want is as much air coming into the zone as possible. So if you can set your discharge air temp to as high as perhaps 60 degrees, that's typically what the limit would be. This would cause your VAV zones to open up as much as possible and get as much of that ventilation in the space as can be done. And of course, with the epidemic mode, that's all built in. You don't have to make those changes. All right, so what are the energy implications of doing this? We've covered this in detail in past webcasts, and I'm just going to give a summary here. There was an ASHRAE study that we saw where a chiller was moved from 15% outside air to 90% outside air, and we saw that twice as much chill water was required. But recently, NREL, in a first of its kind study, did a total calculation and model of what the energy implications for following the guidance is in 4 different modes. And this was done in all of the US climate zones. So we can predict for what climate zone you're in, what the energy implications are for following the guidelines. And so here's a quick summary. This is just one slide of the webcast we've done in the past. If you're really interested in this topic, you should go back to our website and take a look at those recordings. It's really interesting. I want to show you that what these bars mean. This first bar right here is for this particular climate zone, how much energy would be consumed in normal operation. The second bar is showing the amount of energy it would be consumed if you follow the CDC guidelines without any automation available. Just follow the guidelines. They're saying just keep your system on and keep it running all the time, because that's the best you can do if you don't have any automation. The third bar is the 75F epidemic mode. So this is following the guidelines to the letter, but doing it in the most energy efficient way. As you can see, there is a little penalty over normal operations, and this is corroborated by studies that we did. I presented in one of my previous webcasts that we actually saw in the field. We saw an 18% increase, and it looks like NREL's study is fairly close to what we actually saw in the field with one of our customers. And then this last bar, where we're getting down pretty close to normal operation, is the epidemic mode with partial occupancy also added, so that we're splitting up the content of the building, on one day versus another. Okay, so we have an opportunity for some Q&A coming here. We've got some, let's see. We've got some questions here. Has anyone done estimates for increased costs in HVAC operations due to the increased ventilation? Yes, it varies a lot by the region. So we just answered that question. I think that question came in just before I presented the NREL study. So we'll just take a look at another one. In places like California, inland, where temperatures tend to be in the 90s and above with relative humidity hovering at the 20% mark, what do we do regarding that 40 to 60% relative humidity inside the building? Thank you for asking that question, Andre. I believe that in your case, you should seriously look at humidification equipment because the indoor relative humidity is a serious matter when it comes to the COVID transmission. With only 20% indoor relative humidity, those droplets will be very small, and they will travel much further than 6 feet, according to the ASHRAE study that we cited. Okay, here's another question. How can I follow the guidelines across my portfolio if buildings are using different equipment types and or different and existing DMSs? Okay, so that is one of the benefits of using a system like this. The system is compatible with many different types of equipment. Pretty much any kinds of equipment that you would find in commercial building are all supported, and all of the OEMs that are available. We also have interoperability with existing DMSs using BACnet IP, and so we can be compatible with those existing DMSs in those cases where we need to. So we're going to move on to the best part of the presentation with, let's just see, with Dalkia. Daniel and Eric, I'm really looking forward to your part of the presentation. I'm just going to move on to the first slide for you.
All right, thanks, Bob. So I'm Eric Moser with Dalkia. I head up national accounts and particularly healthcare and hospitality. And then we have with us today Daniel Smith as well. He's one of our business development managers and has a great background in controls for HVAC. So Dalkia, our real core mission is to reduce energy and greenhouse gases in existing buildings. So we're going out to existing buildings and we're changing out lighting to LED. We're putting in controls. We're changing HVAC equipment, installing solar, and then potentially installing battery storage or backup generation or combined heat and power. And really the one thing that really knits all this together is digital services. So as we're implementing these things, giving people a higher level of automation, central visibility, and being able to take a great deal of data and make it simple and make it understandable. So Dalkia is part of the EDF family. EDF is one of the largest utilities in the world. And in the US, we have a renewables group that builds typically utility scale wind and solar. We have ourselves, Dalkia, focused on existing buildings. And we have Aegis, which is a combined heat and power manufacturer for generating on site. Next. So really our typical customers are large customers with a nationwide footprint where we're doing multi-site, multi-measure, turnkey solutions. We're going into existing buildings, re-engineering, what was it originally designed for 20, 30 years ago? How can we make it more efficient today? And typically we're focused on kind of infrastructure equipment. We're not really changing anybody's process, but what we may change is their boiler, their air compressor, lighting, chillers, and a lot of times leaving the existing equipment, but adding more automation and controls to it so that it can run more efficiently. And then also looking at where it makes sense to add on-site storage, generation, and solar. Here's a map of projects that we've done over the past 5 years, and they're across a variety of sectors. There's 47,000 locations, or 4,700 locations where we've installed projects. And our real mission is trying to install energy efficiency and help customers save money. Our customers have $100 million in recurring annual savings based on the projects we've implemented in the last 5 years. So really, when's the best time to invest in energy efficiency? You may say in the middle of the pandemic may not be the best time. We've got businesses that are fighting for survival, but really energy efficiency is an investment. We see some customers that lump these projects in with typical capital spend and typical maintenance work. And really, I think that's the wrong mindset to have. If you have the parking lot that needs repaved, the RTU that needs replaced, and the roof that needs it, it really is trying to find out which one is going to fail first and try to mitigate that. For things that have a return, it really should be separated out and focused on ROI projects separate from CapEx and maintenance. I always say, when's the best time to buy Amazon stock? Probably 10 years ago. And it's the same with energy efficiency. Viewing it as an investment, you really want to do as much as you can, as fast as you can. And hopefully you've already done projects in the past. But this really leads us to the scale question. And I'll go to the next example where showing a customer that had, a customer that had 200 locations, and what they originally looked at was energy efficiency projects. They implemented one pilot and then said, okay, well, if we're going to do this, it's a lot of money. So we probably need to spread this out over the next 4 years. And really, if they look at financing the solution and making the investment sooner, implementing over a 12-month cycle, this ends up saving $500,000 more over a 10-year period. The financing would be paid off almost at the time they would just be breaking even on CapEx from the savings from the projects. So after year 6, the slope of the curves here is the same. They're going to get the same savings long term, but the CapEx model really would never catch up to implementing it sooner. And obviously, if you had the money, you should just pay cash and implement it even sooner. But financing could be cash flow positive throughout. The real point is the sooner you can get to scale, the more savings you're going to capture. Next. One of the things we also try to leverage is utility incentives. So the utility programs are set up there in the US. They're giving away $4 billion a year on energy efficiency. And we have a great deal of expertise on how to apply and maximize those incentives, what the best markets are. I've shown here the amount of money by state and then as a percentage of their revenue for the utility companies. But what we see a lot of times, if projects are implemented on a site-by-site level or at the property level, a lot of these utilities are missed. Some of the incentives may not be applied for. Putting in a system like 75F, you may apply for electric incentives and miss out on the gas savings. Really, we know where the best savings are for electric and gas. Next. So in preparing for this and talking about working at scale, I wanted to highlight a few observations. We have some customers that try to implement a program by pushing it down to the site level and having the staff at each site implement projects. And really what we see is, if you ask 100 people to do the same task, you're going to get it done 100 different ways. Everybody has different skill sets and different workloads. And so it may be a long time before projects are actually implemented. Same thing with service providers. We see companies that try to implement solutions across the country and try to pick a local vendor in each market. And again, you're going to get a real variety of results. So we also see people, okay, well, if I can't use different service providers and push it down to the property level, maybe I need to go and do everything. And really, it's going to be hard to implement projects on a wide scale with an individual. Really what you need is a team and really parallel processes so that you can implement across a portfolio in a quick manner. Program and a programmatic view. So there's always going to be exceptions. There's going to be some site that you go to implement a controls project and they actually need to upgrade their equipment or their equipment has failed. And that if you go and cherry pick all the best opportunities, you're not going to end up with your whole portfolio being updated. You're going to end up with a mismatch of some sites that have great savings and some sites that have none. So really, it's better to look at it instead of on a site-by-site level, looking at it as a program as a whole, and that the justification should be the larger picture and the larger savings. And I think the other piece to this is any way you can automate processes, it's going to end up with a much more scalable system than manual processes and different solutions at each site. So I think those are some of the reasons that we really like the 75F product, because it helps to address a lot of these concerns. Go to the next one. So what do we see in the field? I said before, we work in existing buildings, and really we see all kinds of different conditions. So these are pictures from a customer site that we went to in early July, and they were all from the same location, but one of them, has coils that have been damaged over time. And so when the ASHRAE guidelines are saying to increase the outdoor air to the maximum, if you put it at 100% outdoor air or whatever it was designed for 15 years ago, your current system may not be able to reach the previous design state. This site has an outdoor air damper, and the damper was manually forced closed and the actuator removed. So again, this site is not getting any outdoor air, and definitely an issue. We commonly see, standard programmable thermostats set to hold. So, back to Bob's point, this is just going to be running all the time, and the occupancy is probably not 100% of the time, all the 24/7. So at the same time, with non-network thermostats, who knows what it's set to? The picture in the upper right is a broken belt on an exhaust fan, and so keeping the amount of outdoor air and keeping the building in balance, the exhaust fans are critical to keeping that balance. So with the exhaust fan not working, you're going to not be able to bring in as much outdoor air. The picture in the bottom right is clogged filters, and the ASHRAE guidelines are saying to replace filters with a higher filter media and to replace them more frequently. And we commonly see customers that haven't replaced them at all. And I think these are some of the issues that drive towards, there's got to be a better solution than going up on the roof and checking and seeing. There's got to be a smarter way to do things. And I think that's what we'll talk through, but that's one of the reasons we're really excited to be working with 75F. Go to the next slide.
I just want to point out, Eric, that when we implement epidemic mode, if your exhaust fans are not working, find out right away. It's very obvious what happens to a building when it's not balanced. So that's a good point that you've made.
Yeah, and I think you'd see the same thing on if your economizer's not working or the outdoor air damper's not opening, you're going to see that in the analytics as well.
Yeah, but we're going to take an opportunity right now for another temperature check. This is another set of questions from you all. I really do appreciate your participation in this. This really helps us understand where you're at. How many buildings are in your portfolio? If you would just select one of those, I'd appreciate it. So Eric, with those pictures that you showed, you said that was just here in July.
Yeah.
Was that building occupied yet?
That building is occupied, and yeah.
Yeah.
So really, they're definitely not in compliance. Obviously we're working to correct that, but working in existing buildings, we see all kinds of issues.
Yeah, that's what I was going to ask you. When you go on site to do your energy control measures, do they fix all of those things that, like the examples you showed in your photo? Do they just take care of all that?
I think it's typically in the past, and I know Daniel's going to make this point, but typically in the past, this was all around comfort. and nobody viewed this as a safety concern. And so
Right.
in the past, there were a lot of times where we would find some things like this, and it was around comfort. So some fixed it and some did not. Some say,
Okay.
oh, my building's still working. Why do I need to fix this? And it, really, if you look at the energy and the energy savings, it's you can understand why.
Yeah.
But it varies.
Well, it looks like our results are back. So let's just bring those results forward and see what we had. So a majority of people, just about half, 1 to 10, with a pretty good percentage, 21% at 100 or more buildings. So really glad you tuned in, because this content, of course, is designed expressly for you that have these multiple buildings in your portfolio. All right, so let's keep going. I think at this point, it's Daniel's turn.
Thanks, Bob. So as Bob said, my name's Daniel Smith. I'm with Dalkia Energy Solutions, and why we work with 75F, I guess going back to my background before I joined Dalkia, was I've been for 16, 17 years a BMS contractor, so installing large complex control systems anywhere from $100,000 through to I think the biggest one we did was like $3.5 million. And so I came to Dalkia and they said, hey, we want you to come in and implement some of the work you've been doing across our portfolios. And we've got a lot of existing customer base that we can utilize some more energy efficient control strategies. So I joined the company and we started flying around the country looking at sites. And the biggest challenge I was coming up against was we were looking at sites that they didn't have a control system and they needed one, or they didn't have one, and to put a traditional BMS in was not only overkill for the application, but it was expensive. And so I put some quotes together, and we're putting in some pricing that doesn't achieve an ROI that our customers expect and know us for. And so I had to forget everything that I'd ever learned about BMS and products, and go back to the drawing board and find a solution and a system and a process that would be effective with our customer base, and not just on building and system types, but across the the entire geographic spread of the United States. So I went to some trade shows and we found a product, and fortunately someone told me to do a competitor analysis, and I had 100 tabs open on Google, every thermostat you could possibly look at, and I found 75F. And so why that background is important to differentiate was, after speaking with Bob, I realized that for scaling across a portfolio, we could install very quickly. A lot of the sites we look at, we could do an install in 3 to 10 days, depending on the site, and we could achieve a 2 to 4 year payback. So it's a very disruptive price point. And I think one of the keys there is bringing those two together. It's a very quick installation. We have a node, a thermostat, and some sensors. It's a very simple system, all wireless, and we can go and install this stuff local to the equipment without the wiring, and within a couple of days we can power up, and then boom, we're in the cloud, and we've got remote visibility of that site, which is key for us because we're looking at hundreds of sites from Boston to Hawaii. So that works very well for us. And then the other key was, when we're doing these installations across the country, having a traditional BMS setup, it was more difficult to have a visibility across the country and have a snapshot with one system of exactly what's going on. So, Bob, if you go to the next slide. Ultimately, the install's one part, but the end game is what do we do after the project? So remote portfolio management was a big key for us partnering with 75F. So the keys for us here was We just want visibility. Even without control and optimization, visibility is a massive win to be able to see it, what's going on across a portfolio with, as Eric said, different workloads and skill sets for their engineering staff, different systems and deployment and processes in every location. So we had some uniformity across a portfolio, and we have visibility. Secondly is the remote management and control. So a lot of the times when I go to a site and I see an existing BMS, we have, I think Eric's favorite line about it is, I'm not sure if he mentioned, is it's a dusty computer locked in the basement, and the sensors are out of calibration, the dampers are maybe locked shut, no one's looked at them, not driving, no actuators on there, and it's just been left to go out of commissioning. So so we can have remote control and optimization of the site, and we can report on that and have accountability for not only what we've installed and how it should be working, but also what's happening at a site level. And then the third piece is the ongoing optimization. So we're always looking at energy optimization. So how's the system working to reduce the energy costs, achieve a payback, and save the customer money? So we come in, we have an energy baseline, we do a project, we lower the energy baseline. But then the problem is we leave site and then we start getting creep on that. And so we want to be able to not just optimize it once, but optimize it ongoing throughout the life of the installation. So we have energy optimization, but then one of the things that I never looked at before was the operational optimization. So we found that a lot of times we have potentially an unskilled engineer on site, and an RTU goes down, or they get a complaint for temperature. So they put a phone call in, they called the local HVAC guy, he comes out, and it's on average about $350 per service call. Now, by them putting the site putting the call into us rather than to the HVAC contractor, who's definitely going to go out, he's not going to look at that remotely, there's always going to be a fee applied. Now, we're not going to prevent every emergency dispatch, but we can get rid of a lot of them. And we found that the savings on emergency dispatch, removing emergency dispatches, we can save as much on the operational side as we can on the energy side. So we found that as a massive benefit. Next slide, Bob. And then, the last two slides were, it was just its efficiency and controlling the visibility in a non-COVID world. That's how we would implement a project. Now, I've been on a number of calls where people are asking us about bipolar ionization, UVC. Can we change control sequences? And yes, we can do all of those things, but to go out to 100 sites, 200 sites and make those changes is challenging. And then, newsflash, CDC changes their mind, right? This is a new thing. No one's totally sure on the answers, and so we get a change in guidelines. And now, what do? We go back out to 100 sites and change them? Probably not going to fly. And so the epidemic mode on this, which is just a bonus, really. This came along after we partnered with 75F. And when we move in a world from comfort and energy to compliance and safety, it's flick of a switch, and now the building is moved in line with safety and compliance. And not only safety and compliance, we can report and message on what's happening in the building: air quality, CO2, VOCs, what is the humidity level. That will come standard with the 75F offering.
And one point I just wanted to make, as people are going back to work and wanting to know what has changed in the building, what are you doing differently, this tracking and trending becomes more important. So my biggest issue with BMSs is that they're typically locked in the basement with restricted access. My second biggest issue is that they're a real-time view. They tell you what's happening right now. They don't tell you what's been trending over time. And so in the past, we've used CO2 sensors for minimizing outdoor air when there's less people in the space, bring in less air. Now I think we could trend the CO2 levels to show that you didn't have too many people in the space, that it wasn't too occupied, and that you've been delivering the same level of CO2 that you have in the outdoor air in the indoor space. So really an indicator of how much fresh air you're bringing in. And I think all these things that people in the past, if you weren't in the field, you didn't know this. I think there's going to be a lot more messaging that has to happen to employees, to customers, to tenants about these metrics in the BMS that now can be shared, tracked, trended, and reported on.
Those are some really excellent points. And before you go to your next slides, why don't we take a moment for another quick poll, the one about the different measures that you're considering taking. That's it there. Yeah, let's take a look at that poll. So here what we want to know is what COVID-19 HVAC mitigation measures are you considering? Select one or more of these, please. I just thought this would be good, Eric, based on the content that you're just providing now, because we know that ventilation is the primary recommendation of ASHRAE and CDC, but quite a few people have been asking about some of these other, I would call them supplemental measures. When you go to ASHRAE, for example, you'll see that they really don't offer them as the primary measure, but there are some discussions in both the CDC and ASHRAE about some of these other ideas. So we're just going to take a quick count of what people are looking at to supplement, or what strategy they're primarily employing. Yeah. So we've got we'll just get those results up here now. I think it looks good. Yeah. Looks like it's settling it out. So fortunately, about 80% of you are looking at maximizing outside air ventilation, which is awesome. That is what the science supports. We've got UVC a third, bipolar ionization a third, and a different measure. There's actually 4 or 5 that I've been hearing about. So that must be what those different measures are. Okay, so at this point, I would just like to bring it back to Daniel to finish the presentation.
Thanks, Bob. So, and that's a great thing. We've been having, over the last couple of months, a lot of conversations about all of these measures. And the reason that we revert to 75F is, firstly, we're not infectious disease experts. So we want to follow a standard and a guideline. So, going with the CDC and ASHRAE creates that standard. Secondly, it's not just a cost, there's a return. So when we install a system now and we have it in epidemic mode, it's not as energy efficient, but as soon as we feel comfortable, or the customer feels comfortable to flick that switch back to energy saving mode, now we're going to start capturing energy savings again, and there's a return on that. And secondly, it's just the versatility and the ability to move quickly and adapt an entire portfolio with the click of a button. Next slide, Bob. So I'm going to just zip through our process quickly so we can get some Q&A. But I think, as Eric said, some of our customers will try and implement projects themselves, and a lot of the times they come back to us. And I think it's our ability to not just have a process that we've tested over time, but the resources to implement that across hundreds of sites at a time, and within a time scale that captures those savings in a shorter period of time that we don't lose, as per Eric's graph. And so first of all, we have a customer call, and it's data collection, utilities, drawings, and any information that the sites can tell us about their HVAC and what's going on. And then we'll analyze that data and look for where are the high leverage sites that we can look for a quick win and demonstrate the capability of what we can do. Secondly, we follow that up with an audit, a site evaluation. We model the costs, savings, and put together proposals. And then we go ahead with the upgrade. So 75F is obviously a core offering for us, especially right now with everything going on, and any other energy efficiency measures we can find. As per Eric's slide, we're looking also for, what's the state of the equipment there and the setup, because there's no good putting new controls on an old rusty box that doesn't work. So we're looking for a holistic solution that's going to deliver a result for the customer. And while our techs are still at site, they're turning it on, and then boom, we've got visibility and they're live in the cloud within 60 seconds of power on. And then step 4 is managing and report. So that's the ongoing optimization. And we will, we'll do a quarterly review with the site usually, so that we can capture all the feedback we can and make sure that we're trending in the right direction for energy and operations. And I think that's probably a good time to stop for a last Q&A.
Awesome. Okay. Let's see. For questions for Dalkia, can you send me to that section of the questions here? The first question is, what does the solution cost?
Yeah, so I guess the two things I say is, number one, it's significantly lower than a traditional BMS, based on the simplicity of the components and the quick install time. But the second point is key, is we tend to work with our customers on an ROI. And so, we are dependent on geographic location, temperature, humidity, incentives. We're looking between a 2 and a 4 year payback typically.
Okay, that's good. Let's look at one more Dalkia question here. Let's see. If we want to test this, how long would it take to get to an installation?
So typically we would schedule a quick call to talk through kind of the opportunity, to understand what the existing conditions are. And then we'll schedule an auditor to come out and take a look in detail at the equipment. Generally, if everything lined up into place, we could have systems installed in under a month. Usually the rate limiting factor is more of customers and the customer decision-making process. So we try to, again, run that in parallel, where we're going to talk budgets before visiting the site, so we can start down that path to an actual implementation and try not to waste any time.
So Daniel, I'm just curious, and we've done a bunch of these now, in terms of length of time it takes to figure out what the solution is and how to put it in. How does this compare with what you used to have to deal with in your prior life?
Yeah, so once I've got the information I need, I can, depend on backlog, get a proposal out in a week. But really, it's taken me a couple of hours to put a proposal together. Whereas on a traditional BMS installation, it could be, anywhere from 2 to 5 days, depending on the system. Obviously, 5 days is a larger system, but
yeah,
on a smaller system, it's still 2 days, and it's a real in-depth look at for most of that, to try and find what I need to monitor, to install, engineering, what does the customer want. Whereas with 75F, it's built on simplicity, which
right.
I think is one of the big benefits.
Okay. So here's a question. Is the cloud data available through an API to integrate into a CRM currently being used to manage work orders and tickets? I'm going to pick up that one, because that has to do with that one it has to do with our API set. So obviously we can use BACnet IP to integrate with other BMSs for, let's call it, traditional points, read write of set points and schedules and things like that. But in order to pick up information and get it over to a work order or ticketing system, BACnet IP integration would not be really adequate, right? So that's what our Haystack native API set is for. That's for deep integration into the system to pick up notifications or alerts or conditions and set rules, and then through the API bring those into another cloud and provide some type of, perhaps even unthought of solution. So that's what the API is for. So let's see. Here's another one for Dalkia here. Let's see. If we have a mix of buildings, what if we don't have? What if we have? Let me get my language right here. What if we have a mix of buildings that don't have current controls?
So a list of
Yeah, I've messed that question up for you. What about a mix of buildings and that either have existing controls or don't have controls at all? And what do I do with that variety?
Yeah, I think that everybody has a mix of buildings. Even if you have a retailer that has been building buildings and has 100 of them, they're going to have several generations or varieties of them. They're going to have different equipment of some that may have been there before. And so everybody has a mix of buildings, and really that's one of the things we liked about this system is it's a preset, pre-programmed, very versatile system versus a custom solution at every site. And so with that, it tends to allow more scale and quickly, and really be more compatible with existing equipment out there rather than a bunch of proprietary solutions that only work with one certain brand. So.
Okay, thank you. Well, that brings us right up to the hour. There's a whole bunch more questions to answer, but we will be following up and providing those answers in the next day or so. And thank you very much for attending. And don't forget, we have a regularly scheduled webcast in 2 more weeks. And in the outro, we'll give you the details for that. We'll see you then.
Thanks a lot.
Thank you for attending our webcast. Our next webcast is coming up on August 25th, and we'll be partnering with the International Well Building Institute to talk about their perspective on reopening buildings during COVID-19. We'll see you then, and stay healthy.